Hello. Before I begin today, I'd like to thank the hosts and organizers of the AI Forum Agritech. I sincerely appreciate the opportunity to share how at Amazon Web Services, we are helping our agriculture customers build a more sustainable future. The topic of sustainability is near and dear to my heart. At a very young age, I was concerned about pollution and interested in environmental issues. I chose environmental science as my major in college and started my career at the Environmental Defense Fund. I joined AWS a little over 1.5 years ago to head up business development for our agriculture industry vertical. And prior to this, I was an investor in the renewable energy and agriculture sectors, and then worked with early stage companies in the agriculture technology, or what we call ag tech space. I am really excited about the work we are doing with our customers at AWS to build their businesses in agriculture and also foster broader collaborations across the industry. So who is our customer in the agriculture industry at AWS? This is a question that I get asked all the time, and since everything for us at AWS and Amazon begins with our customer first, I'd like to start here to set some context. We look after a very diverse group of customers, which reflects the complexity of the industry. Our customers include the seed, crop protection, and fertilizer companies, equipment manufacturers, large enterprise-scale fruit and vegetable producers, food processors, and integrated protein companies. Some of our customers manage value chains that reach all the way through to downstream verticals like CPG and retail, and we'll collaborate with our colleagues that cover those industries to bring that combined expertise to bear. We also look after a number of ag tech startups whose products span this entire value chain and are a diverse mix of hardware, software, and analytics companies. This is just a small sample of our customers, and as you can see, it is a very diverse group. Given this diverse mix of customers and our breadth and depth of experience across the agriculture value chain and broader food system, we have developed a perspective regarding some of the unique sustainability challenges and opportunities within the industry. If you are familiar with the industry or follow any of the news about agriculture in the business or popular press, you are probably familiar with some of these statistics. Our world population is expected to grow by about 25% from where it is today. Yet we already consume the majority of freshwater resources, about half of our arable land, and depending on how this is measured, we are a significant contributor to greenhouse gas emissions. As a global community, it is imperative that we really learn how to do more with less. I have to be honest though, these statistics make me very uncomfortable because they are big and daunting. They leave one feeling uneasy with a sense of urgency, but also overwhelmed by the enormity of the problem. Because the key question for everyone here today, and really everyone on the planet, is what can I do? How can I be part of the solution, whether it's in my work or in my choices as a consumer? And I consider myself fortunate in my role at AWS to be supporting our agriculture customers every day to be part of this solution, helping them build a more resilient, sustainable, and inclusive food system. So what is the connective tissue between daunting global environmental challenges and the practical realities of running a business within agriculture? The industry is undergoing a massive transformation to respond to these issues, and data is at the heart of this. AWS customers are leveraging technologies like IoT, machine learning, robotics, computer vision to make their operations smarter and more efficient. Data analytics and a culture of innovation are really transforming the industry, and we are delighted to help our customers build this future. Where is all of this data? If you're willing to humor me for a minute and do a visualization exercise, I'd invite you to close your eyes and pretend you are holding a handful of soil in the palm of your hand. In that one handful, there is information about soil type, nutrients, and microbes, all of which tell a story about the optimal seed genetics for that ground. And if we widen our lens to the field, this includes data regarding pest and disease pressure, irrigation, weather, and satellite imagery. And if we zoom out even further, there is data to be collected regarding storage, transportation, food processing, and cold chain management. Agriculture is a data-rich industry with a wealth of information that can provide actionable insights for optimizing operations throughout the food system. So the question is, how can this data be captured and staged and enriched to develop sustainable agriculture solutions? I am going to briefly walk you through a few of the industry solutions we have developed for our customers, and then I will share stories of how agriculture customers are innovating with AWS. During our visualization exercise, by the way, thank you very much for humoring me, we discussed the wealth of data sources from one handful of soil all the way through to a more comprehensive view of the food system. And thank you to robust venture capital and government investment, there is an ever-increasing array of devices and sensors to capture this data. With continued innovation, the per-unit cost of these devices has come down considerably, making them more accessible. They're also more ruggedized, meaning that they can hold up in outdoor environments. AWS is working with customers across the industry with our IoT and machine learning services to streamline the aggregation of all these different data streams and distill insights from farms, barns, and processing facilities. All of these sensors and devices present an unprecedented opportunity for collecting data. However, there are still many challenges. Rugged environments, intermittent connectivity, and heterogeneous data types, from soil moisture to genetics to imagery, coming in from fixed and mobile sources, all of these create very unique challenges in agriculture. AWS is helping customers reliably capture data, manage it for interoperability, and deliver insights to enable real-time decision-making. This starts with a very comprehensive approach to IoT solutions. Every customer's business is unique, and we don't believe in a one-size-fits-all approach. So our solutions include devices, local data collection and analysis, and cloud services to collect, store, and analyze this data. And ultimately, with our breadth and depth of IoT services, spanning from the edge all the way to the cloud, our customers can build applications for virtually any use case across a wide range of devices and sensors. So once we've enabled our customers to capture all of this data, what is the next step in making it valuable? We've developed a set of resources that enables our customers to combine their unique data with data from other sources to provide context and derive insights. This solution is also structured to eliminate data silos and help our customers foster collaborations more easily across their own organizations. I know from my time in the industry that many organizations, from large enterprises to smaller startups, are all accessing and maintaining third-party data sets, such as weather and satellite imagery, to provide context to their own data sets and train their machine learning models. But for every single one of our customers to spend time acquiring, storing, and updating these third-party data sets is undifferentiated heavy lifting. We are building upon the AWS Registry of Open Data and AWS Data Exchange to create a unique asset for our customers. Today, the Registry of Open Data on AWS hosts over 280 data sets, including those which are directly applicable to agriculture use cases. And we are continually building out these data sets based on customer feedback, which is really valuable. We also know from customers that they want all of their data in a single repository, such as a data lake, and they want the flexibility to analyze the data in a variety of ways. So our goal with this solution is to provide that ability to aggregate relevant data into that one central data lake and combine it with agriculturally relevant data sets from other sources to provide context and lay the foundation for analytics that deliver true insights. Once data is captured, stored, and managed more efficiently, it is ready for machine learning applications and other analytics that can deliver actionable insights. And we are going to discuss how a few of our customers are doing this today with products and solutions that are also making agriculture more sustainable. Let's start with the most important decision made on any farm: which seeds to plant. One of the greatest opportunities for making agriculture more efficient and less resource intensive is by optimizing seed genetics and by choosing the best genetics for particular soil types and regional environmental conditions. Bayer Crop Science is using AWS IoT services to manage the collection, processing, and analysis of seed growing data from their research farms. The solution captures multiple terabytes of data from seed planting and growing in the company's research fields across the globe. The big challenge that we worked to solve here was the amount of time that it takes to get that data out of the field and into the hands of the analysts that need it. Using AWS IoT services, Bayer Crop Science can now provide seed data to their analysts in just a few minutes instead of the few days that this used to require. This is a really game-changing opportunity for those R&D programs in developing seeds that can optimize the balance between yield, resource intensity, and resiliency to stress like drought or disease pressure. Once that seed is planted, then it needs to be managed for the right applications of crop protection and crop nutrition products. BASF's digital farming application is one such example running on AWS. This is what we would call a farm management information system. It's a platform that gathers several different types of agronomic data from farms across a region, runs analytics to distill insights, and then offers recommendations based on those insights. This application has a scouting capability that is designed to improve sustainability. This feature can detect over 100 common weeds with 80% or greater accuracy. This helps detect these weed pressures early on in the season and enable a farmer to be much more targeted and prescriptive in the application of crop protection products. This is currently used by over 3.5 million farmers in over 100 countries. And it's a great example of a technology that is improving outcomes while reducing inputs by enabling farmers to be more targeted and efficient in their applications. Another great in-field example that is one that is focused on water efficiency. Cropx is a soil sensor and analytics company that seeks to help farmers improve crop yields with less water by using more accurate in-field soil sensors instead of only relying on above-ground data. The solution captures data from thousands of global soil sensors and combines that soil sensor data with above-ground data sets, such as imagery, weather, topography, and soil data. All of this data is then analyzed by algorithms to provide insights via the Cropx web or mobile app. Cropx is able to help its farming customers better manage irrigation and eliminate over or under irrigation. In fact, their technology has been validated in the field with 30% demonstrated water savings across multiple crop types with a 10% yield increase. AWS infrastructure and services have also supported significant growth in the company's business. Since its launch in 2017, the company, which is based in Israel, has grown through acquisitions and is now operating in the United States, Australia, New Zealand, and Europe. There's been a lot of attention in the popular press about the importance of pollinators and the decline in the populations of these important species. Globally, over 70% of all fruits, vegetables, seeds, and nuts are pollinated by bees. However, bee populations are declining, with some colonies facing complete collapse. In fact, between 30 and 40% of bees die every year worldwide. So real-time feedback on colony health is crucial. Utilizing AWS services, BeeWise has reduced the average bee mortality rate to less than 10% in their robotic AI-controlled beehives, which are called bee homes. They utilize precision, robotics, cameras, computer vision, and artificial intelligence to help large portfolio beekeepers monitor the internal workings of their colonies from afar. Special sensors flag diseases, pests, hunger, and more. And commercial beekeepers who have anywhere from 1,000 to 10,000 hives get a notification on an app when a poor condition is discovered, so they can respond quickly and manage much more efficiently at scale. If we begin to move out of crop protection and take a look at harvest, one of the biggest issues we must tackle in building a more sustainable food system is the elimination of food waste. Each year, approximately 1.3 billion tons of food are lost or wasted. That's about 1/3 of all the food produced in the world. And approximately 1/3 of this waste happens in the field before the food is even transported for distribution and sale. Intello Labs, based in India, the US, Singapore, and Sweden, is using computer vision to optimize harvest quality and timing. Intello's customers are fruit and vegetable growers, wholesalers, and retailers concerned about quality, provenance, and traceability. To help them, Intello created an app that captures the image of the fresh produce sample, like apples or tomatoes, and gives the quality metrics, such as color, size, and visual defects. Buyers can make a decision on whether to accept that sample or reject it, thus reducing value risk and waste in the supply chain and ensuring that the highest quality food reaches consumers. And finally, in our last example, I mentioned that 1/3 of food waste happens in the field, while another 1/3 is lost in distribution and transport, usually due to an inconsistent cold chain or inefficient routing and logistics. Carrier is a global leader in building refrigeration solutions, and they monitor more than 15 million cold chain products annually. Carrier and AWS are collaborating to develop Lynx, a digital platform to optimize cold chain operations. Lynx unifies the highly fragmented cold chain to reduce food spoilage, support end-to-end visibility, and increase efficiency throughout the various stages of refrigerated storage and transportation. Lynx will use AWS IoT services to collect, integrate, organize, and analyze data from Carrier's large installed base of refrigeration equipment and monitoring solutions. The solution will then combine this with sources such as traffic and weather reports to provide a comprehensive view of cargo location, temperature conditions, and external events that could impact cold chain operations. Remember earlier, we talked about the importance of those third-party data sets. This information will feed into a data lake where Carrier can apply machine learning and identify potential issues that could impact cargo and run sophisticated analytics to develop recommendations for improving outcomes. Overall, this solution will reduce food waste and lower logistics costs. These are just a few examples of what customers are building on AWS to move towards a sustainable future in agriculture. Sustainability is top of mind for almost all of our customers. And as they continue to make commitments within their businesses to reduce the resource intensity of their products and services, we are going to continue to support incredible innovation. Thank you for taking the time today to learn about how Amazon Web Services is working with customers in the agriculture industry.